Hello everyone, this is Mr. Appel, and today we're going to look at this special situation in our geometric mean. I'll connect it back to that a little bit later, but this special situation being we have a big right triangle, triangle ABC, and that has to be a right angle. It's a little hard to see there, but that has to be a right triangle. And then there's an altitude from the right angle drop to the third side, or a perpendicular drop to the third side, which here is that segment CD. Okay? And what's interesting is, in this situation, all three triangles formed, the green little one on the left, the smaller one on the right, and then the big triangle, all three triangles are similar to each other because they all share angles. You can prove that easily by the angle-angle theorem. So we have a bunch of similar triangles. What's tricky is trying to see what corresponds with what. And what's interesting is that we have shared sides. We have sides that appear in more than one triangle. And the sides that do that are this one, BC, right? Because BC is a side of the triangle on the left as well as the triangle on the right. We have AC, this side here, which is a side of the small triangle on the left as well as the big triangle ABC. And also BC over here, which is a side of the giant triangle as well as the big triangle on the right. Whoops. Actually, I went out of order, but that's okay. We'll just do this first. So what we're interested in is focusing on each of those three sides that appear twice. One way to help you sort of remember that those are the three sides is if I draw a little curve through those three sides, right? That curve goes through the three different sides. Again, what's important about those sides, they appear in two different triangles. And you'll see why that's interesting in just a minute. It's so interesting, in fact, that I'm going to add a couple eyes up there, and you'll notice it makes a smiley face. But of course, that smiley face would look weird if it didn't have this little right angle nose. That's maybe a cheesy little way to remember that this only applies when that big triangle is a right triangle, when that's a right angle. So draw that curve through the three sides, right underneath that right angle, and that might help you remember what's going on here. Okay, so first I've isolated two triangles. I've isolated the big triangle ABC, the blue one, and the red triangle, the smaller one on the right, which is triangle CDB. And I notice that CB is the side that appears twice. So these are similar triangles, so I want to write a proportion that includes CB. So CB in the red triangle, so CB in the red triangle, what does that correspond with in the blue triangle? Well, notice that CB is actually the hypotenuse of the red triangle. It's opposite the right angle. That's an easy way to recognize it. So that should correspond with the hypotenuse in the blue triangle, which is AB. All right, so this side corresponds with that one, hypotenuse with hypotenuse. Okay, but we want to bring CB, this CB in as well. We want to include that. So what does that correspond with in the red triangle? Well, in the blue triangle, CB is the longer of the two legs. So that should correspond with the longer of the two legs in the other triangle, which is this one, DB. So the long leg in this one corresponds with the long leg in this one. So we can say that DB corresponds with CB. Okay? And you see here that CB appears twice because it's a side of both triangles, but it doesn't correspond with itself, which is kind of a weird concept. Okay, so that was with the big triangle and the triangle on the right. Now let's look at the big triangle and the triangle on the left. Again, there's three options here. We're now focusing on AC, because AC, which is that leg, appears in both triangles. So we're going to write a proportion for that one. So AC in the green triangle is the hypotenuse. So that should correspond with the hypotenuse in the blue triangle, the hypotenuse being the one opposite the right angle. So that's opposite AB in the blue. So green to blue. And then what else is going to correspond with AC? Right, AC is in the blue triangle, so we're doing green to blue, so it should be green to blue. That's another way to kind of keep it straight. So what's going to correspond with that? Well, AC in the blue triangle is the shorter of the three legs, so it should correspond with the shorter of the three legs in the other triangle, which is AD. Okay, so AC in the green corresponds with AB in the blue. AD in the green corresponds with AC in the blue. And so when you see that AC appears twice in that proportion. One more example. Now if we're going to focus on just the two smaller triangles, the green and the red, what's the side that appears twice? Again, draw your smiley face. It goes through CD. CD is in both triangles. So in the green triangle, let's write our proportion again. All right, we're going to do green to red, green to red, green to red. So CD in the green triangle corresponds with what in the red triangle? Well, CD is the longer of the two legs in the green triangle. So it should correspond with DB, which is the longer of the two sides in the red triangle. And then we also need to include CD in the red triangle. So what corresponds with CD in the red triangle? Well, again, CD is the shorter of the two legs in the red triangle. What's the shorter of the two legs in the green triangle? That's AD. And there's your proportion. So what we have is three different proportions we can write. One for AC, right? One for that leg, one for that altitude, and one for that leg. And each of those proportions, we can include that side twice. So hopefully that helps. See you soon.